she ended up 35 years with more than double, with 88,000. Yes. Perfect. Okay, moving on. I believe there is a problem in Pearson with this formula. So would you like me to show you again how to enter this formula in the graphing calculator?
Yes.
Yes.
Okay, so I'm going to copy it. So P is the principal, of course. And then we have R over 12. I don't need that extra parenthesis in there. So we're going to look at one of these problems. It doesn't matter which one we pick. R divided by 12, and then 1 plus R divided by 12 power n, and then 1 plus R over 12 to power n minus 1. So I'm going to stop sharing because I need to explain that the graphing calculator requires parentheses here, here, and here. So you cannot enter the formula the way you see it here. You have to have parentheses around the R over 12, parentheses again around all this. Although, since this is just one factor, you could omit. So these can be omitted. But here that you cannot. Absolutely carved in stone. These have to stay because there is a sum or a difference of two terms. So without looking at this formula and realizing that we need parentheses definitely here, optional these two, but definitely these, you're not going to get the correct answer. So now let's choose one of the problems. And this is the last thing we need to do in R.1. So we can finally move on. Okay, so let's look at okay, so Fermat's Last Bank makes a card loan of 18,000. So I'm going to copy 18,000 at 4.6%. Annual interest, of course, with a loan period of 3 years. What is the monthly payment? Because we have to pay the money back now, right? So we take a loan of 18,000 at this interest rate and for 3 years, and we have to pay it back. How much do we pay back per month? That's the question. So this is the monthly payment. So where does this fit in the formula? Anyone? Please try. Where do I put 18,000 in the formula?
Do you replace it with M?
No, that's the M. That's what we have to determine.
Would it be with P?
Of course, that's the principal. Yes, that's what we borrow. What is R?
0.046.
0.046 divided by 12. 1 plus 0.046 divided by 12. And what is N?
3.
It's a silly question. There are only 3. Yes, thank you so much. 1 plus 0.046 divided by 12. Power 3 minus 1. Please remember, we don't have brackets. Well, I mean, we can use brackets. We can find brackets, but that's what I mean. Parentheses here, parentheses here. They can be nested parentheses or brackets.
I have a question.
Yes, please.
For the enhanced homework, we kind of had like a similar problem.
Yes, that's why I'm showing this how to enter in the calculator. Yes.
So instead of 3 years, they did 36 months. Does that make
Very good, very good, very good, very good. So the number of years, n is in years. So 36 months will equal 3 years.
You can't see the screen.
Oh, of course you cannot. Something, yes. If I touch or move the table, yeah. So 36 months, 3 times 12 is 36. So n has to be in years.
I can't see it again.
N has to be in years. Okay, so we can go back here. Here it is. N is in years. N is always in years. So if we go back to the formula, when you see this problem in Pearson, it will say for a total of, oh, okay. Okay, so the formula is in months. Thank you for pointing that out. Well, the formula that I have in my calculator, I put it in years. So that's why you're correct. It's better to check. Always better to check. Okay, so
the screen isn't showing again?
yes. I'm not sure which connector is doing that issue. Okay, so in this case, I have to enter it as 36 months. As I said, I have this formula in my program in my calculator. Every time I need to borrow money, it's already in there with 36 with months. But the formula, we always have to carefully read what they said. So I jumped ahead and I said, oh, it's like the formula that I have in my own calculator, but in the way they presented it, they want months. Fine. Okay, so we'll see in a moment if it's reasonable. We should always ask ourselves, is it reasonable? Okay, so 1800, no, yeah, 18,000, sorry. So now, in parentheses, 0.046 divided by 12. Open again, 1 plus. Do not perform these calculations piece by piece. Please do not do that, please. They have to be all at once, in one line, or 2 lines, or whatever, but not one by one. And then you calculate one parenthesis, then you calculate the second. No, please do not do that, please. Okay, so I have another parenthesis, 1 plus 0.046 divided by 12. Power 36 again, come down from there, minus 1, and close the parenthesis. So notice that this set is for what's inside, and this set is for the whole denominator. And when I click enter, yes, it makes sense. 536, so 536.25. And when we multiply this by 36 months, we will know exactly how much we will give back. Okay, so this is the monthly payment multiplied by 36. Then we will know how much we pay. We will pay $19,304.98 minus $18,000. So what is the cost of the loan? Cost of loan. The cost of loan would be 19,304.98 minus 18,000. This is the cost of the loan. So it's 1,304.98. So we're borrowing 18,000, but we have to return the interest, the 18,000 plus the interest. So we are returning 19,304.98 but we borrowed 18,000. And this is the cost of the loan. How much? $1,304.98. Any questions? So thank you for pointing that out. This particular formula requires months, not years. Thank you. I appreciate that. Now I think we're ready to move on. Any questions for me? Is there anything else? So let's look at R.2 functions and models. So the first thing I would like to look at, let me share my screen again. Back to page 21. Good. So in this page, when we talk about functions, can anyone remind us what a function is? Anyone remembers what a function is? So a function is a correspondence. So this is a function. To each x value, it corresponds only one y value. It's a correspondence. So this x corresponds to this number, this x corresponds to this number, this x corresponds to this number. This is a so-called domain. And this is, anyone remembers what is this called? Anyone? So this is domain of the function, and this is where the y values are. What is it?
The range.
The range. Good. So what cannot happen is the same x to go to two y values. But can two x values go to the same x? Yes. Two x values can go to the same x, but the same x cannot go to two different y values. So this is a function. Back to our domain and correspondence range. Domain, correspondence, and range. Determine whether each of the following is a function. So let's choose one. You choose anything from here, any number that you would like to look at. Anyone? What about 10? Let's take a look at 10. Okay, my page 3. So in number 10, on page 21, we have a set of numbers, x. We have a correspondence. And the correspondence, they say, is the cube root. And we have another set of numbers. Is this a function? In other words, my question is, for every x value, do I get just one y value? So for example, if I have 27, what will be the correspondence through the cube root? What will be the cube root of 27?
81.
The cube root.
It's not 81.
No, it's a number that I raise to the third power to get 27.
3.
Yes. So the number is 3. Good. What about -1? What would be the correspondence for -1? Which number we cube to get -1?
1.
But 1 cubed does not equal -1.
Is it an imaginary number?
Not with the cube root. Very good question. Thank you so much. Not with the cube root. You're correct if you say the square root. Yes, this is not real, but not with the cube root. Which number we cube to get -1?
-1.
-1. Awesome. Good. So do you think that this is a function or not?
Yes.
Yes, it is a function. It is a function. Each x value corresponds to only one y value. Perfect. Perfect. Okay, very good. How do we evaluate functions? How do we evaluate functions? That's our next step. Let's take a look. So we have different situations. Let's choose a function here and evaluate it. Which function would you like to pick so we can evaluate it?
26 or 27.
Okay, let's look at 27. In 27, the function f is given by f of x equals 1 over x plus 3, everything squared. And they're asking us to find f of course, I'm going to put this as like in a correct order as much as possible. 0, 4, and then they want a, and then they want x plus h. Perfect. And this is our f of x. I don't need that anymore. Good. So I see there is a chat. Let me see. Okay, good. So when you ask me, if you give me this function and you say evaluate it, the first thing I do